Good evening everyone. Today I am going to start the new topic, functions. Okay, functions. So as you have learned the function in class 11 standard, I just want to recall about what is function. Just what is function? Suppose we have two non-empty set A and B, then a function from A to B is a rule or method or correspondence by which we can relate each and every element of set A with a unique element of set B. Each and every element of set A with a unique element of set B. So let us draw the Venn diagram. Our things will be more clear now. So A and B, these are the two non-empty sets, and F is a function. Okay, F is a function from A to B. So each and every element of A must have an image here, or must be related to some element of B, No element should be left here. In case of relation, we may have some elements in A which do not have any relation with the elements of B. But here, in case of function, each and every element of A must have a relation with at least one element of B. No element should be left here. So a function can be considered as a restricted case of relation. So this whole set is known as domain. This is domain, same as relation. Here the whole second set, this is B, is known as codomain. One is domain, another is codomain. And the elements of A are known as pre-image. And the elements of B which are related to some elements of A are known as image. These are known as images. And this image set will from the range. This image set will from the range. These are the basics of the function as we have learned in class 11 standard. So the whole set is domain and elements are known as pre-image. The whole second set is known as codomain. The elements which have relation with the elements of A will form the image, and this set of image will form the range. These are the basics of this. So F is a function from A to B. We can express like this way. So next we are going to discuss about the types of functions. Different types of functions. Okay. Here I am going to discuss about few functions. Number one, one function or injection. One function or injection. The same name, one function or injection. Suppose we have a function from A to B. Is said to be 1, 1. Is said to be 1, 1 or injection if different elements of A have different image in B. Different elements of A have different image in B. In Venn diagram, we can show like this. Okay, A, this one is B, F is a function. Now, if suppose A, B, C, D is here, then A is related to suppose P here, Q, C is related to R, and D is related to S. So different elements of A have different images. Some elements may left here, no problem. For 1, 1 condition, we must have different element of A must have different images. So this is 1, 1 and injection function. 1, 1 are simply injective or injection function. So second one we are going to discuss about this. Second one is number 2 is many one function. Okay. Many one function. A function f from A to B is said to be many one if at least two elements of the set A have the same image in B. At least two element of set A must have the same image in B. So in Venn diagram it will be more clear. So A and this is B. f is a function f from this one a, b, c, d, p, q, r. Suppose a and b have the same image p, and this is c have the image q and d have the image r. So here at least two elements have the same image. So that's why it is known as many one function. It can be happen that so many elements have the same image. So this is many one function. Next one is number 3. This is onto function. Onto function or surjection. Onto function or surjection. Okay, a function f from a to b is said to be a surjective or onto function if each and every element of the set b, is an image. That means no element should be left in the codomain. So every element of codomain is an image of some element of the domain. So in Venn diagram we can show that like this: a, b. F is a function from a to b, a, x, b, y, c, z, d, p, like this. No element should be left here. That means here the range must be equal to codomain. So range and codomain must be same. Then we call it a onto function. Range must be equal to codomain. Then we call it an onto function. So then next one is number 4. That is 1-1 correspondence. 1-1 correspondence or bijection. So this is simple one. So a function f from a to b is said to be 1-1 correspondence or bijection if it is both 1-1 and onto. Both the condition 1-1 and onto must be satisfied, then a function is said to be 1-1 onto. Next one is into function. So f from a to b be a function, then it will be called an into function if at least one element of the set b, that is codomain, at least one element of this set must not be the image of any element of set A. That means in Venn diagram to be f a, x, b, y, c, z, and r is here. So r is not the image of any element of set A. In this case it is called an into function. So these are the different types of functions. Now I am going to discuss few examples here so that the topic will be more clear for you. The first example will be number 1. Prove that the function f from real number to real number defined by fx equal to 2x is 1-1 and onto, or simply bijective. So we are given that what f is a function from real number to real number. So we are writing here f is a function from real number to real number, and it is defined by fx equal to 2x for every x belongs to the real number domain. So we are going to prove it one by one. First one is 1-1. For this we will take two different elements from the domain. We let x1, x2 belongs to our domain such that their images are equal. we are taking any two elements from the domain and we suppose that their images are equal. If we are able to show that the elements are also equal, then it is 1 1, or otherwise it is not 1 1. So then we are moving to the next step. This will be equal to, as per our definition, it will be 2x1 equal to 2x2. Dividing both sides by 2, we get x1 equal to x2. This means that we take any two elements from the domain and we suppose that their images are equal, and by considering that one we are able to show that the elements are also equal. That means different element of the domain have the different image in codomain. Therefore f is 1 1. Next, on. So for the part on to, we are going to take an element from the real number to real number. This is the function here. F. We'll take any element y from here, and we suppose that there is a pre-image in x, and thereby we are going to find the value of x. If it is valid, then our function will be on 2. We let y belongs to our codomain. We suppose that there exists an x belongs to our domain such that the image of x is y. The image of x is y. So here we are going to write the definition here, 2x equal to y, and thereby we calculate x equal to y upon 2. So clearly, whatever be the value of y does not matter. If it is divided by 2, it is always a real number which belongs to domain. So as we are taking y as arbitrary element from the codomain, and we are able to find its pre-image. So every element of codomain is an image. That is, here the range and the codomain is equal. So f is on 2. So we can say this is also bisective because it is satisfies all the conditions 1 1 and on 2. So next example I am going to take this one. Prove that the function f from real number to real number defined by fx equal to modulus of x for every x belongs to real number domain is neither 1 1 nor 1 2. We are going to take this one. Prove that the function f from real number to real number defined by fx equal to modulus x for every x belongs to real number domain is neither 1 1 nor 1 2. Same as earlier, we will proceed. Here we first write that function real number to real number defined by fx equal to modulus of x. The first 1 1 part we are going to say. So we have, as we know, that 2 and minus 2 are two different real numbers. These are belongs to the real numbers, and this is belongs to domain. So as per definition, f of 2 will be equal to modulus of 2, which will give us 2, and f of minus 2 is equal to modulus of minus 2 equal to 2. That means in Venn diagram, if we show in the side of this answer, here f is a function, so here 2 and minus 2 have the same image 2. 2 and minus 2 have the same image 2. Here 2 is not equal to minus 2, but we see that f of 2 equal to f of minus 2. Therefore f is not 1 1. Here f is not 1 1. Clearly it is not 1 1. Next, it is sufficient to prove it by a counter example. Need not to prove it theoretically. So next, that will be the onto part. So for every x belongs to real number, modulus of x is greater than equal to 0. So whatever be the value of x does not matter. If it is a real number, then it will either equal to 0 or greater than 0. So in this case, the range will become 0 to infinity, which is a subset of R codomain, which is become a subset of codomain, That means range is not equal to codomain. So therefore f is not onto. So in these two examples, I shown that one is 1 1 and onto, and in the second example, both are not satisfied. That is not 1 1 and onto. So I think this is clear. And now I am going to explain one more example. That is equal to that is example number 3. So prove that the function f from natural number to natural number defined by fx equal to x square plus x plus 1 for every x belongs to an domain is 1 1 but not onto. So prove that the function f from natural number to natural number defined by fx equal to x square plus x plus 1 for every x belongs to an domain is 1 1 but not onto. So let us solve it. Fx equal to x square plus x plus 1. Sorry, I have to write the function first. F is a function from natural number to natural number, and it is defined by fx equal to x square plus x plus 1. So for 1 1 part, we let two different elements x1 and x2 belongs to n, that is domain such that we are taking two elements from the domain such that their images are equal, as I said in the earlier cases in the first example. So as their images are equal, so according to the definition it will be x1 squared plus x1 plus 1 will be equal to x2 squared plus x2 plus 1. 1 is getting cancelled on both sides, then we can have x1 square minus x2 square plus x1 minus x2 equal to 0. Now we need to proceed further to get the answer here. This is the identity, so we can x1 it by x1 minus x2 multiplied by x1 plus x2 plus x1 minus x2, that is equal to 0. We can see that x1 minus x2 is a common part, so we take it common, so we get x1 plus x2 plus 1 equal to 0. Okay. Clearly here x1 minus x2 should be equal to 0, because why? x1, x2 are natural numbers. So therefore x1 plus x2 plus 1 cannot be equal to 0. As these are natural numbers, so sum of three natural numbers cannot be equal to 0. So that's why this part must be equal to 0. Here we get x1 equal to x2. That means we are able to show that different elements have the different images. So therefore f is 1 1. F is 1. Next, for onto part, so we have 1 belongs to n. This is 1 codomain. Since 1 is a natural number, this belongs to codomain. we suppose that there exists an x belongs to n. This is domain. We suppose that this element of codomain have a pre-image. So that is x such the domain such that we are taking this like this, such that f of x equal to 1. So here we get x square plus x plus 1 equal to 1. Further simplifying, we get x plus x equal to 0. So we get this type of thing here. So we can take x common, so x plus 1 will be equal to 0. This gives us x equal to 0 comma minus 1, and this cannot be the elements of natural number, or they cannot belongs to natural number, because 0 and minus 1 are not natural numbers. So these are not belongs to the natural number in the domain. So these elements are not present in domain. So 1, which is an element of codomain, do not have any pre-image. So that's why f is not onto. So that's all for today. So in the next class I will discuss about composition of functions. Keep watching, subscribe, like and share. Thank you.